make a start. So welcome to the, what month are we in? June seminar. I'm really happy to introduce Ralitza Dimova, who is at Manchester University. Ralitza is a development economist and will tell us all about behavioral responses to man-made disasters today. I'm especially thankful to Ralitza for giving the seminar today because it's a public holiday in the UK. And Ralitza could have been celebrating Queen's Platinum Jubilee, but decided to talk to us about man-made disasters. As usual, could you please mute your microphones during the seminar, but feel free to unmute if you have any question to ask. And also note that the seminar is being recorded. Okay, over to you, Ralitza.
Hello, and many thanks for the invitation and for being here. I can still join the celebrations after the seminar. The issue that we are looking at in this paper, which is very much work in progress, just the initial touches, is behavioral responses to man-made disasters, which we believe is very topical today, as topical as ever, with all the conflicts that we are experiencing and increased discussion about use of nuclear energy, among many others. My co-authors are Anna Bazou and Ulrike Grote, which I hope will join at some point. And the data was collected by Ulrike's team. Essentially, what we are trying to look at is the risk profiles of individuals located in an area that is affected by a man-made disaster compared to those who stay in areas which are less affected. And risk preferences are important to examine because, as we know, they affect any other aspects of economic behavior. The main question that we want to answer is whether individuals in the affected areas are characterized by greater risk tolerance, which, as we'll explain in a second, we see as a corollary to the willingness of people to pay for the risk, to avoiding the risk for health and life. There are also additional questions that we want to answer. We want to see how risk tolerance changes over time in parallel with the change in the influence of the man-made disaster. And given that people that stay in the affected areas are not a randomly selected sample, we want to see whether our effects, our main results, are robust to matching on observed characteristics which are correlated with the potential of people to out-migrate from the affected area. Now, we understand that it's not sufficient to look only at observed characteristics, but it's very difficult to find appropriate instruments in this case, and finding bad instruments is worse than not instrumenting. Our context is Agent Orange in Vietnam. Our paper speaks to three different types of literature. One is the literature on the willingness to pay to avoid a risk for health and life, which is developing very fast around location at different radius from areas characterized by nuclear energy use or disposal of nuclear energy byproducts. And a very prolific area on risk tolerance in the face of natural and man-made disasters. And indirectly, we also speak to the literature on migration in the face of natural and man-made disasters without really estimating migration. I think that the most prolific area of research is the one on risk tolerance in the face of natural and man-made disasters. And much of this literature is data-driven. Roughly half of the papers find that disasters increase the aversion to risk, while the other half finds that the result is the opposite. Disasters actually decrease risk aversion. Most of the papers are just regressing risk preferences on a measure of disaster, which is taken as exogenous, while others use difference in differences. And only a very small proportion of the studies take into account the potential of people to outmigrate from the affected or risk-prone area, which is what the literature on the willingness to pay to avoid the risk for health and life is explicitly taking into account. Some of the earlier literature on nuclear hotspots looks at residential prices at different radius from the nuclear hotspot. The idea is that people that are very risk averse would locate as far as possible from the affected area, and prices as far away from the nuclear hotspot will be very high. So this association between high residential prices and distance from the nuclear hotspot is taken as higher willingness to pay to avoid a risk for health and life. So this is the link between risk preferences, willingness to pay for avoiding the risk, and distance or location away from a hotspot. This type of research has been criticized because costs for relocating could be very high, and residential prices could be affected by other factors other than the risk or the perception of the risk related to nuclear power. That's why subsequent research has been done experimentally with people estimating directly the willingness to pay to avoid risk. One of the most interesting studies that we found is the one by Zweifel and co-authors in the context of Switzerland. They estimate willingness to pay to risk at different distance from a nuclear hotspot, and they find the expected result that the willingness to pay to avoid risk is much higher the further away people are from the disaster-prone area. But this result weakens when they account for the people's perceptions of the degree of the risk. Similar research has been done also in developing countries. For example, Nkosi and Dick Gang do the same estimates of the willingness to pay to avoid risk in the context of South Africa. And their results are much weaker than the ones in developed countries, probably because of differences in institutional and governance framework and differences in people's perception related to the risk and the information that they get of how high the risk is, but also probably due to higher costs of relocating. This is something with which the literature on migration in the face of natural and man-made disasters takes into account. And much of this literature is actually in the context of developing countries. Very nice, some literature reviews are done by the International Displacement Monitoring Center. Their reports have summarized huge amount of literature in this area. And as expected, they find that human capital and physical endowments increase the chance of people to outmigrate from risk-prone area, where the risk could be either man-made or natural. But there are also interesting findings with respect to people's perception of the degree of the risk. Some people are just not sufficiently informed. Others are informed, but they underestimate the risk, and that's why they don't migrate. Yet third group properly estimates the risk, so it's both the information is there and they properly estimate the risk of the disaster, but they still refuse to outmigrate because of other reasons. And one study that we find very interesting is the one by De Bruin and Mueller in the context of migration in the face of natural disasters in Ethiopia, they find that in the context of poorly defined property rights, people that have larger land ownings are the least likely to migrate, because they are afraid that once the disaster is over, they'll find it difficult to reestablish their property rights. So we position our study in these three literatures. Technically, we are doing what the middle set of studies doing. We estimate risk tolerance in the face of natural or man-made disasters, but we also try to give it more theoretical backing by getting insights from the literature on the willingness to pay to avoid a risk for health and life. So rather than just having our data determine our results, our null hypothesis is that risk tolerance will be higher in affected areas compared to less affected areas. And indirectly, we also take into account the potential of people to out-migrate from this area, and we look at the characteristics which are correlated with this type of choice. Our context is the one of Agent Orange in Vietnam. As we know, this chemical was sprayed massively across much of the territory of Vietnam between 1965 and 1970. I have produced some concrete information on the right-hand side here. 80,000 million liters of this agent was sprayed mostly on rainforests, wetlands, mangroves. The idea was to increase the visibility, to defoliate, and thus increase the visibility for military operations, and also disrupt the food supply of the Viet Cong. What is interesting in our context is the differences in half-life of the agent, depending on where it has fallen. It is fairly short if it has been spread on soil surfaces, about 1 to 3 years. So presumably this is already over. But if it is buried in subsoils, it can last for 20 to 50 years. So which is interesting that now we are reaching the final point of this time span, given that the end point of spraying was 1970. But if it is in rivers and sea sediments, it could go on for 100 years. A huge number of people were directly affected, but then generations afterwards were affected mostly with different types of illnesses produced, mostly cancer, but also defects to future generations. There is quite a bit of information on Agent Orange currently in Vietnam, and still some people that are presumably affected are receiving benefits. So we believe that the information is there. And currently, people that currently live in areas that were affected strongly by Agent Orange are still potentially exposed to the side effects of the agent. We use data from the Thailand-Vietnam Socioeconomic panel, which was collected by Göttingen University. It started in 2007 in 3 provinces in Thailand and 3 provinces in Vietnam. In Vietnam, the provinces are Ha Tinh, Tua Tien Hue, and Dak Lak. The data is mostly representative for the rural population, and the 3 provinces are spread across the country, one in the northern part, one in the middle, and one in South Vietnam. We use data from 5 waves, where 2,200 Vietnamese households, or approximately 8,000 individuals, were tracked over time from 2008 to 2007. We use these 5 waves because they have behavioral modules. The dataset is fairly rich and contains the typical living standards type characteristics. But unlike similar data sets like the Living Standard Measurement Survey of the World Bank, we also benefit from the availability of a behavioral module. So how did we choose our treatment and control areas? Our methodologies is difference in differences. So as I mentioned, we have 3 provinces, Ha Tinh, which is in the north, Tua Tien Hue in the middle, and Dak Lak in the south. So what is interesting is that the areas that were affected the most by the Agent Orange are the areas below the 17 parallel. So Ha Tinh was the least affected province among the affected areas. So if we look at information on provinces below the 17 parallel, we see that even in the areas in the middle and the south of the country, there are differences in the effect of the Agent Orange. According to the Aspen Institute, which provides data, which is perhaps the most widely used for studies in this area, Tua Tien Hue, the area in the middle of the country, was the third most affected among most affected provinces in the by Agent Orange in the ranking by the institute. And if we look at, if we compare in the left-hand side map, Tua Tien Hue and Dak Lak, we see that Dak Lak was somewhat affected, but it's in a much greener region. Tua Tien Hue is very orange, which means that it's one of the most highly affected areas. So in our estimation, we define Tua Tien Hue as a treatment area and Ha Tinh and Dak Lak as the control areas. And we try to look at the effect of being exposed to the man-made disaster on behavioral preferences. So how are behavioral preferences measured? We have a risk preference measure, which is based on a Likert scale. So essentially, people were asked to rank their willingness to take risk on a scale from 0 to 11, where 0 is highly unwilling to take the risk and 11 is being very willing to take risks. This measure has been used widely in the literature, and in the context of this specific survey, it was experimentally validated. So people, also those, the individuals that collected the data, also used experimental methods, Grossman-Eckers methodology of eliciting preferences to validate this measure. And across several studies, they found that it is a good representation, good measure of risk preferences. There is an additional measure of willingness to invest, which we just use for robustness check. People are asked, if you won a certain amount of money, how much would you be willing to invest? But our main measure is the Likert scale based measure, which we used both as it is, as a continuous measure of risk preferences, but also give it a binary measure of being risk averse, where we take the lowest 5 categories, give a value of 1 of being risk averse to the lowest from 0 to 5 and 0 to the highest risk taker categories. So this is the equation that we are estimating. Our dependent variable is a measure of the respondents' behavioral response to man-made disaster, which we measure both as categorical value and as binary measure of being risk averse. Our main control is the treatment agent origin area, and we also test the hypothesis that the willingness to take risk will change over time with the decreasing effect of the agent. So we also correlate the agent orange area, the treatment area, with a trend, aside from all the additional characteristics that are used in the literature on estimations of risk preferences of individuals. So here is just a brief look at the key independent variables that we are using in our regression.
Sorry, Ralitza, if I may ask a question, what happens if people are moving over time? Can you follow individuals here? Is this what you're doing? Or?
So this is actually quite difficult to do because so we have information on who has moved and who has come to the area, but we don't have precise information where exactly they moved from. So we know that whether they moved from an urban area or from a rural area, and whether they moved from the same province or from a different province, but we don't really know whether they moved from an area that was more affected by the agent orange and or area that is less affected. So,
so your people can move away, so to speak, yes, to avoid the risk area. What?
Yeah, so this is a major shortcoming, and that's why we simply, so what we simply do, and we are planning, in fact, to send it to a non-economics journal, we just take into account the fact that the sample of people that stayed in the Agent Orange province are non-randomly selected, and we use propensity score matching to at least account for observed characteristics which are correlated with the potential move. So the typical variables that will either help or obstruct the movement of people to the area. But yes, this is a shortcoming.
Okay, thanks, no problem.
So what is interesting to observe across the two areas, and the results, just the descriptive results, are very logical. We see that consistently with our expectations, risk tolerance is significantly higher in the Agent Orange provinces, even though the willingness to invest is lower. So we take this as a first evidence in favor of the our willingness to pay to avoid risk hypothesis. We also see that, as expected, people that belong in the Agent Orange province are less educated. This is consistent with the possibility that those that have higher levels of human capital are more likely to out-migrate. And another interesting observation is that farmers, there is, even though all these areas are similarly rural areas, there is a greater chance to be a farmer in a non-Agent Orange province, which is also consistent with the fact that the greatest danger comes from Agent Orange that is still under the soil. So what is interesting is that the self-reported measures of correlated shocks are higher in the non-Agent Orange province. So if we find a significant effect on risk tolerance, it's not due to just any shock. It would be most likely to the shock that we are most interested in. So looking at our results, which are still polishing, we see that they are consistent with our expectations, both for the sample as a whole and for the matched sample, where we have used propensity score matching using both the nearest neighbor and kernel matching techniques. We see that people in the affected areas are characterized by significantly greater risk tolerance, even though the effect on willingness to invest is not significant. We also see that over time, the risk tolerance decreases, which is consistent with the fact that we are moving towards the end point of effectiveness of the agent, at least the ones that is buried in the soils. But people in the affected areas still exhibit lower willingness to invest compared to people in the less affected areas, and results are robust to the matching techniques. So if we are to look first at the first stage, the intermediate stage of the propensity score matching, we see once again that our results are consistent with expectations. We see that there is negative association between staying in the agent orange area compared to the less affected areas. If people have higher levels of education, but also greater physical ownings, like land ownings, affect positively the chance for people to remain in the area. So in this sense, our results speak to both types of literature, the ones that say that endowments increase the chance of out-migrating, but also specific types of endowments push people to stay in the area. So just to summarize, we try to get insights from 3 types of literature, and our results, at least our preliminary results, are consistent with the theoretical framework of the literature on willingness to pay to avoid risk, in that people who remain in the Agent Orange area are characterized with greater tolerance to risk compared to those residing in the areas that are less affected. Risk tolerance decreases over time, which is consistent with our knowledge that the effect of Agent Orange decreases after several decades. And we also observe that higher education is positively associated with the chance to not live in the affected area compared to the control areas, while larger land holdings are positively associated with the chance to stay in the affected areas. And obviously, we recognize that due to various data and other constraints, we are only able to control for observed characteristics when we take into account the non-randomly selected sample. And as of now, we haven't figured out a better way to control for unobserved factors. And as I mentioned, we are not able to, we don't have sufficient information to track people who have out-migrated. We can account for them. We could re-estimate the equation, just taking out the people who have out-migrated, but that is as much as we can do.
Okay, thank you, Alexa. Plenty of time for questions. Could I just start maybe, this is slightly related to what Klaus was asking. In terms of I mean, I don't know how the previous literature has looked at this, but in terms of asking, in terms of looking at the behavior, I suppose people who are living there, I mean, in the Vietnam case, probably most of the people moved in there, but in general, you could be either living there and then it became, let's say a nuclear plant came after, you had started living in that area or whatever. So the risk aversion or risk kind of behavior of people who are already living in the disaster, so to speak, that became a disaster area is going to be different than people who, in a way, decide to move in to the area. I mean, and does that, is literature kind of able to capture? I'm just thinking about your external validity kind of issues in relation to that as well, in terms of these are going to be the only those people who are going to be moving in, I assume. Because this was, whatever, 60s, 70s, the disaster area created around that time. So these are the people who moved in, and therefore their risk aversion is basically different. Migration into the area versus staying in a disaster area.
Yeah, so it's difficult to compare the ones that have moved from non-disaster areas, but we could at least check whether people that have in-migrated, no matter where from, have greater risk tolerance. It's possible, and in fact, what we originally were trying to see is whether people would move because they expect to receive benefits, because we know that people still receive benefits if they have been affected. So it's possible that really risk tolerance people just consciously moved in order to get the benefits.
So in terms of those who were already living there, then it is basically the decision between staying or out migrating.
Yeah.
And that, I assume that's a different behavior, isn't it? I mean, that's a different risk taking or risk aversion, whatever you want to call it, behavior than moving in. And so anyway, I know in your case it doesn't. You can't capture that because you don't. You have no people moving in. Klaus has a question, and then I after that.
Yeah. It's. I mean, at the aggregate, essentially, we are looking at people that have ended up being there, whether they in-migrated or just stayed there. But yeah, we don't have enough information to account for it. Sorry, I think that I.
No, that's fine. No, thank you.
Yeah, I mean, I have another question related to the same kind of issues here, not about migration. So if I understand, okay, there's variation with about risk preferences across Vietnam. Okay, so that's, now you measure this after the risk event, yes? Now, is there a way to compare this distribution with something similar before the event across Vietnam to see to what extent we have seen real changes? Well, why I'm asking this is because there is, of course, a competing literature outside of core economics, which is related to genetics, yes, claiming that risk preferences, among other preferences, are largely genetics, determined by genetic factors. Well, if this would be true, then, well, what you measure is not so clear. Even then, of course, actual behavior may change temporarily. People may be depart after they have received the traumatic disaster. They maybe react a little bit, but after a while it would converge back, bounce, perhaps, that's a theory, yes, bounce back to what is the standard one, which would explain that over time, your effect becomes smaller. So is there any way to check? I mean, I of course know you cannot test for genetics, but not in your sample. But can you at least explore that problem or that challenge for interpretation?
Well, unfortunately, we don't have, and given that the event happened in the 1960s, 1970s, it's absolutely impossible to do a before and after. But there is huge literature. In fact, there was a big article recently in the Journal of Economic Literature looking precisely at this question of whether risk preferences are genetically given or whether they can change. And that's why there is a huge accumulation of studies that try to look at the effect of different shocks. But you are right that this is possibility, perhaps in a not very technically sound way, to show that potentially people can converge back to the type of preferences that they would genetically have. But on the other hand, there is literature on the life cycle in developed countries, which show that even without major shocks, people's risk preferences change over the lifespan. So younger
these studies often ignore that the preferences have been formed by relationship to parents, yes, so to speak. So if you control, I have a study on this. I will send it to you, where we show that as soon as you bring in parental preferences, the temporary effects disappear.
Mm-hmm.
So it's relatively stable also over lifetime.
Mm-hmm.
That is, I mean, it's just for one big country, a developing country, Bangladesh, but it's, of course, there might be different studies somewhere else, but at least there are, you know, okay, so you're right. It's true that in many countries it is.
Mm-hmm. Yeah, well, this goes back to the big debate on nature versus nurture, with respect to not just behavioral characteristics, but pretty much anything. And it's a never-ending story. It's just I personally don't see how one can find a clear answer to these very complex issues.
Thanks.
I'll look for your paper on Bangladesh.
Ira?
Yeah, so I think this is related to Klaus's question, but it's this middle conclusion that I'm struggling over. So migration is a reaction to the impact of Agent Orange, and who moves and who doesn't move based on their risk tolerance, right?
Yes.
So is risk tolerance endogenous with the impact of Agent Orange?
It could be.
Because this is what this statement seems to be saying to me.
Yeah, I mean, we need to think of how to account for that. So it is true that people with specific type of risk preferences out-migrated. At the end, we just observe people that stayed or moved in. And account for the possibility of this is a non-randomly selected sample, but I'm not sure how precisely to look at the potential endogeneity of the shock in a better way. Do you have any on the top of your head?
Just trying to sort it out.
Do you know how big the assistance from the government was? Because my first thought would be also, can these people afford to move, right? Like it's also an income constraint that I might be really risk averse, but I have nowhere to go and I don't have money, so I can't move. Do you have any information on sort of the financial constraints or how big the assistance from the government was, whether that would allow them to go?
So we have, so that's why when we compared people in the Agent Orange and non-Agent Orange areas, we account for different factors that are associated with their wealth level and land holdings and so on. So in a sense, these type of observed characteristics are accounted for. We don't have information on the benefits. So this was, as I said, this was one of our original ideas, to look specifically at the government benefits and whether people explicitly located to get those benefits. But this information is available only in the last wave, 2017, and it's very few people receive this type of benefit. So there is a lot of information on external sources about this type of benefits, but at least in our data set, which is fairly representative, only very small proportion of the people reported that they have received Agent Orange benefits. So probably at least in these type of provinces, it was not that important, not sufficient to help people to out-migrate. But I'll look more carefully into that.
Klaus has another.
If I may again, yeah, Agent Orange is, of course, a military instrument, so to speak. It was used for military purposes, of course, and so it was highly selective across Vietnam. Yes, it was not used in Hanoi, just as an example, because Hanoi is a city. So there must be a particular population living in areas where potentially Agent Orange was a useful weapon. So let's say rural versus city, is it what it is? If you look at the data you have.
Yeah, so
it goes with respect to the observation that you already have, that you say you link information about these areas to control for this.
Yeah, I need to look more closely. So the provinces in our data set are mostly rural. And from what I have read, but I need to read more carefully because the information is very dispersed. Yeah, I saw that Arnav is raising his hand, so I lost my train of thought. I hope that he'll come to my rescue.
Jump in, Arnav.
Oh, hey, Klaus. Lovely to see everybody. Ira. I'm sorry, I'm hiding, in a cave. So my video is off. So sorry about that. But a quick point, this issue of there are two issues over here. One is the intergenerational transfer of preferences, particularly risk preferences, and then the idea of endogeneity. So one thing is for sure that, the Klaus and Ira, both you guys raised very important issues, is that, one of the reasons why this particular province was heavily sprayed by Agent Orange is because these people were actively helping the North Vietnamese. So technically speaking, they were rebels, or at least sympathizers of the rebels. And that already shows or tells you that they're probably more risk-loving to be actually fighting the government. They were taking risks anyway to be doing so. And then because of that, they got heavily sprayed by Agent Orange. And maybe the persistence of that risk-taking behavior is intergenerational. And we see that even with the population that decided to stay and still live there. So it well may be the case. The problem is that there is no instrument that I can think of, right, that is maybe highly correlated with risk preferences, but has nothing to do with mobility, for instance. So that's where the problem is. The other issue is that the Vietnamese census has very good data. It identifies individuals who are affected by Agent Orange, either directly or are offsprings of people who are actually affected by Agent Orange. But that data set has no data on any behavioral preferences, risk or patience or what have you. So this, this TV-CEP data set is the only one where we find both. And we were trying to, we approached this question by looking at the existing literature on Fukushima, for instance, the nuclear disasters, other man-made disasters, and who stays, who goes. There's a fair amount of literature with nuclear disasters. People have tried to, understand this. So what we tried to do was kind of see if we can replicate some of those kind of methodologies in the context of Agent Orange and Vietnam. So this is the, so that's why I hesitate to say, and Ralitza would agree with me, that, the results shouldn't be treated as causalities, or maybe we should only look at first differences and not really diff of diffs. But I'll stop there. So this is just a little bit of a background as to how we fell into this project, and there is something interesting there, but this issue of indigeneity, of course, is going to dog us throughout.
Ira, do you have a?
Yeah. Since this data sets also includes Laos, right? Or is it Thailand or Laos? No, Laos.
Laos.
Laos,
It's
right?
Thailand. It's Thailand.
Thailand.
It's Thailand. Okay, even better in a sense. I mean, this is crazy, but couldn't that be your counterfactual group?
But it was used in Laos.
In Laos.
Laos.
So I think that whoever gave the
Civil
answer is
War.
probably that the data set also has information on Thailand, but the agent was used in.
It's Thailand, yeah. So you have people in Thailand since same years who assumingly weren't subject to Agent Orange. They could be your counterfactual. Sort of like Georgia is the Mario Boatlift.
Yeah, it could be, but it's also a completely different country which has completely different characteristics. And people that compared, in fact, last week at the conference, somebody was comparing unrelatedly risk preferences across the two countries, and they are very different for other reasons, just different governance structures, different people.
Sure, but that's the beauty of difference in differences, right? Anyway, just another robustness thing.
Yeah.
I don't know, before you come in, I was just thinking a completely different kind of way of kind of turning it around, maybe. So if you think about only those, let's only kind of focus on, because Arnab was talking about that area related to Klaus's kind of argument that this was specific area, then therefore there is this kind of a selection issue. But if you only focus on people who moved in, and not genetically whatever related to, or those generation who were affected in 60s and 70s, so then there are these people moving in, and what one can do this is the other way around in a way, what migration literature has used. So the ease of moving into the, so like the provision of highways, or maybe economic kind of benefits, or the difference in economies of the two regions. So a decision that affects migration, but not it's independent of, in a way, the risk of going in a disaster area, if that makes any sense. I don't know if I'm making a case. Arnab, you might want to jump in. I don't know if you had something else.
You're on track, actually. So what I was about to say, one way, we are still dabbling around and trying to look at various things. So one way to look at this issue of in-migration versus, who stayed, is to maybe, because the risk preferences are captured, the data collects the risk preferences of the head of the household, right?
Yeah.
So one way to do this is to truncate the data set and only look at heads of households who are over 50 years old, right? So technically speaking, you're kind of looking at people who were either born exactly at the time when the last round of Agent Oranges were sprayed, or older, right? So who actually have very personal memories of the event. One way, even if they were not there, at least it was the war was still ongoing technically, born before 1975, for instance. So that might be one way to see if that subsample displays like even stronger risk preferences than the larger sample, or their willingness to invest is even worse than the rest. So that could be one small, but it's not really addressing the indigeneity issue. It's just checking that, okay, if you're close enough or born before the war ended, do you actually exhibit preferences that are stronger in one direction or the other?
I think that we already discussed this issue, but there is a lot of literature on the relation between age in general and risk preferences. So I'm not sure whether we will be able to distinguish between the simple age effect and being born in that era. We will control.
In this case, you'll have the same age group. I mean, 50 onwards. So it's not, yeah.
Yeah, and what I'm thinking that 50 and over is a different sample from 40 and under.
Yeah, that's, I mean, the preferences are definitely going to be different. So you can't say anything about that group, but you can say specifically about that group. I mean, the other option, yeah, I don't know. It's not an easy one to address, I think.
So just for my information, since we have this slide here with data one, the Thailand, Vietnam socioeconomic panel. So that's the data set. And so I was a little bit misreading this. So Thailand is listed here not because it was also attacked by Agent Orange, which obviously it was not, but this is the data set, and this is a kind of comparison group. Yes, you are looking at. That's what.
Yes, so we have completely excluded Thailand. It's just what the data set was.
Yeah, because there's a similar. I mean, Laos was also under attack by the US military. So that would be a different story then. But there you don't have data. Okay. Yeah.
I'm not sure. Arnav, do you remember? Because at the conference they were also talking about Laos. Is data available in that project on that? I think Arnav disappeared.
No, there is no data on Laos. Sorry, it's just it's done in Thailand, and so I can't, I don't think Ulrike is here. If Ulrike could have spoken a little bit more about this. But anyway, so this project, the Thailand-Vietnam Socioeconomic Panel, it started in 2006 because the German government funded this this project, trying to understand resilience, right? So resilience to shocks. So it started off collecting data over these various waves, and the idea was to see coping strategies in response to floods and droughts and rainfall shocks and all that, right? So that was the reason why they picked. I mean, what the socioeconomic panel has been used. It has really been used extensively to study coping strategies. And I think we are the first, the first people who actually are using Agent Orange in Vietnam to kind of even ask, we are not asking coping strategies, obviously, but we are trying to take a behavioral approach to it. So so it is challenging. It is true that there are, three sets of questions. One, endogeneity between Agent Orange and risk preferences to begin with. Second, intergenerational transmission of risk preferences. That's two. And three, even within a generation, the stability of risk preferences, depending on age and income and other household characteristics. So these three we really need to. I don't think we can address the intergenerational because the data just doesn't tell us enough. We can probably address the indigeneity a little bit if we can find something else, right? I mean, for instance, specific roads that North Vietnamese used and which provinces those roads went through. So it's a geographical terrain. So we can use a little bit of the satellite mapping to identify certain routes that simply because of geography were feasible, and use that as an instrument maybe for Agent Orange. But that's the extent of it, though. Seriously, we'll dig around, but these are things we need to highlight in the paper, the limitations part. That there are three issues that we can't completely address.
But Anna, a different way to summarize what I see now, so to speak, is to say, well, Agent Orange has reached its objective to reach the risky population.
Right.
The risk-loving population, so to speak. Yes, I mean, let's assume they didn't become risk-loving, but the objective was to reach risk-loving people supporting North Vietnam.
Exactly. So that could be one, yeah, that would be a good punchline to this, saying that, you know, even for the younger generation, it seems that that behavioral preference persists. So it can become a persistent story.
That's at least a story. I'm not saying that this is the correct one. Yes, I mean, I'm far away from it, but obviously, I mean, given the factors that it was aimed at people who had to take risky positions, these people must have been relatively risk-loving. Otherwise, they would not have done it. And objectively, the US military has well, maybe by chance found the right so-called right areas. I mean, this is all very cynical, but it's a way how we can look or get information out of the data.
But this is a very good point. Actually, we will highlight this fact that, you know, that they're obviously, you know, the reason why they got sprayed is because they were obviously with the rebels, and that already depicts a higher level of risk tolerance. So this is a good point. We will put that in the paper.
Yeah. So intergenerational taming of the biggest rivals.
The intergenerational is a different story, but it's a question how to control, to find out whether these preferences have been already there, yes, or whether it has been created. Now, in a way, you started saying it has been created, yes, and that's possible, but it conflicts with positions saying, well, maybe there are other factors you cannot control for, well, like intergenerational differences and self-selection into areas and so on. I mean, this is all, I mean, to be clear, this is all very interesting data, and it's fascinating to look at it. And the challenge is why we are there, yes? The question is, what can we learn from it? And well, there are these kind of reservations one should mention.
Yeah, so the advantage of this type of studies that collect behavioral characteristics over time is there. So probably in the future, people will be able to answer this question. For example, now in Ukraine, even that the Ukrainian Living Standard survey started before the conflict, so people potentially could look after the conflict, hopefully soon, whether the conflict affected preferences in a before and after manner. But unfortunately, in this case, we won't be able to look at that.
Yeah.
Okay, I think this is a good time to stop. Thank you very much, Ralitza, for a very interesting paper and very interesting data set as well, actually. So quite a lot to think about. Yeah, thanks again for presenting on the Thursday. Thank you very well.
Thank you very
discussion
much.
as well. Yeah, very good discussion afterwards as well. So I'll see you all next month. Until then, goodbye.
Bye.
Thanks.
Many thanks.
Bye. Bye, everyone.